Let me tell you a bit about the architectural process and why most architectural offices are wasting time and money instead of recognizing the trend and jumping at the opportunity to make greater and more efficient architecture for less time, hence less money. In Germany, the architectural process is divided into 9 phases. For our purpose, there is no need to be that analytical. We all recognize 3 main phases: design, modeling, and construction. And under modeling, I do include written documents like the bill of quantities, schedules, and so on. So to simplify even more, I will consider design everything done with a manual or digital pen and paper, and modeling everything done using a specialized software, and construction everything done on the construction site. In the old days, this was a fairly linear process. You would sketch, then you would produce some technical drawings, and then the builders would use these drawings to build. And as an architect, the first 2 areas represented the majority of your responsibility, with the second one occupying most of your time. That is why most pictures of architects in the past show them at the drawing table. And that is why if you walk into any architectural office today, you will not find the majority of people with colorful markers and notebooks. Most of them will have technical drawings and models on their monitor, clicking away. Most architectural offices today stick to this factory line method. I propose a different method, and here's how we will do this. First, I will explain what I propose, then I will explain why that is efficient, and then I will explain how that should be addressed at the universities. I propose that you as an architectural office concentrate on design. Then you hand the modeling part to people specialized in that part of the project, like programming architecture. And we provide humans and machines with files and drawings ready for production. Why would you do that? Well, here's your first reason. Let's say you have a contract for a fairly large building, and you decided you need 20 people on that job. I argue you can now employ 5 people and deal only with the most creative and interesting part of the project, the design phase. Then you take that money you planned for 15 paychecks, take half, put it in your pocket, and give the other half to us, and we will handle the rest. So how come we can do it for half of the money and you can't? Well, that is where experience and specialization comes into play. Construction isn't what it used to be. A0 paper sections and plans are not used that much on the construction site anymore. A lot of elements are produced with CNC machines, buildings are proofed in virtual and augmented reality. Construction companies require BIM files so they can export the data they need, etc., etc. That all propagates backwards into the system so that your modeling phase doesn't have one type of input and one type of output anymore. No, it has dozens of outputs. I'm not talking randomly here. This is what we do on a daily basis. And this is how it looks like. We take the idea from you and then we model everything in 3D. So, we might use Rhino, we might use Revit, and if we're dealing with complex geometry, we will create our own plugins, some in C# and some in C++ if we need to optimize and the speed is important. Python scripts will give us some quick boosts, and Grasshopper will be used to automate some small isolated details. If we're going to do it in Revit, we might use Dynamo, but why not just write a plugin in C# to automate the generation of all those structural columns and beams and connections. Of course, you need static analysis models, and in that model, every beam and column have to be oriented properly and have the right hinges and orientation and loads applied to them, and the right cross-section and material. Well, of course, we'll make our plugin so that they automatically generate all of this on a click of a button. You need a beam joint detail generated for your static analysis program. Sure, we can take our 3ds or Revit file and produce an Excel table or directly a file for your static analysis program. RFM, Oasis, Sophistic. You need a beam representation of your structure? Tekla? Sure, we can program that directly for Tekla, and then you can export it as an IFC and then exchange it with Revit or use the advanced steel. But wait, before you go into production, you will like a virtual reality tour through your model so that you can walk around, change materials, move walls, furniture around. No problem. We will transfer your 3ds or DWG to a Revit file into an FBX file format, import it into a 3ds Max, make some adjustments, import it to a game engine, create a tour, program some interaction in Blueprints or C++, and voila! But you have your model in SketchUp? No problem. Okay, so you have to produce all those walls and beams and columns and connections. We will add lines of code that will generate 2D drawings automatically. DWG, DXF, PDF, and with the title and all the dimensions and descriptions for 10,000 structural elements, no problem, we can automate that. But hey, some production companies want IGS files, and this one wants all beams as step files with all the screws and bolts and holes and weldings inside. No problem. But hey, we found a manufacturer that has CNC machines and they want the NC G-code files so they can upload them directly into the machine. Okay, so we can use Advanced Steel or Tekla, or we program the output files ourselves. Just tell us which version of NC files you want, because there are many of them. You know what, we will do this parallelly in CATIA so that we can handle the details and export better, and we can create the augmented reality for the as-built model easier that way. Okay, I will stop myself here. I can go on, but I will stop. What I have described here is literally a process we go through for one project of a relatively complex nature. And for you as an architect, the most important thing is that we try to keep the input connection very simple, so that you do not have to have headaches about all the software and all the file formats. And the reason we can do it in half the time and half the people you need is because of our experience. And this is where education comes into play. What do architectural students learn during their studies? They learn how to design, and they learn architectural history and city planning and architectural physics and details. Building, not really. They get some tips and hints, but we all know they will learn that part during their career. And how about this modeling part, this bulk that takes the majority of your time? Who teaches them this? They usually do it on their own, along the way. They will have a marginal subject here or there, 1 or 2 semester Revit course or 1 semester Grasshopper course, but that's negligent in comparison to the things waiting for them. So as I argued in many videos before this one, this is a new profession. Who should do it? Whoever wants to. I'm biased toward architects because that is my educational background, and because if you as a university are producing 300 architects per year, then you better teach them to do something that is needed. The days of AutoCAD being the only tool for drawings aside from pencil and rulers are gone. Your drawings are now made in DWG and DXF and 3ds and exported to FBX and RVT and IFC2 or IFC4 to RFM and GSA, and your contractor will want the plans in DXF or PDFs or NC files or for production, including STEP or IGS files. So the question is, who is your file dealer? Who will tell you which file will make you feel good and which will give you headaches? Which file will make you spin in circles and throw up, and which will get you to the next level? For now, it is us, companies like Programming Architecture, and in the future there should be more people educated to do this software juggling. And if you work at a university, think long and hard how you will do it. You might have a professor that is nice and smart and has 350 publications in their CV, but zero experience with this kind of things in the real world. Don't get me wrong, the theoretical aspect and approach are very important, but our profession doesn't mean much outside the physical world. We are builders after all, and knowing how to apply our knowledge in practice is of the utmost importance. So if you do not update your system and teach students how to handle architecture in real life in the 21st century, you will decrease the value of your institution. This is an unfortunate bet I'm personally making because I do less and less with academia, but I'm still trying to help as much as I can, and that is my advice. For all of you who are executing what I talk about on a daily basis, stay tuned, we will go through this together. I already made Rhino developer courses, and in the future we'll cover all other software that you might use together with mathematics and logics behind it. Please share and do not forget to subscribe so that you can get notified when new videos, new courses, new plugins are out, as well as discounts we give you on those courses. In the description there is also a mailing list that you can subscribe to for the info on courses and discounts. Stay free and stay tuned. If you want to create your own cool plugins like Voronax or any of our other plugins, I can teach you how to do it. And if you go to proarchitect.teachable.com, you will see already some of the courses there, the Rhino Developer C++ course or the Rhino Developer C# course. You get small C++ and C# basic courses with them, and in the future you will get to see a lot of other courses on similar subjects. You can enroll in the course, you can see all the explanation here. You have more than 10 or 11 hours of video. The first couple of videos are free, where you can check out if you are able to download the software and create your own plugin, and afterwards there is lots of videos explaining all the basics of the development for Rhino so that you can create your own plugin.